So I want to start off with a multiplying problem like this. What we're going to do, write down 3 over x plus 5 plus 6 over x minus 3. That's a pretty simple kind of adding of two rationals, adding two rational expressions. Not hard to do. If I wanted to actually add them, which actually I'll do here, I would find the lowest common denominator. Easy enough here. And to get that lowest common denominator, this one I'll have to multiply by x minus 3 and x minus 3. And it looks like this one is just about dying. Let's see if this one works any better. Okay, a little bit. And for this one, I'm going to have to multiply top and bottom by x plus 5. Not unusual, you've done this before. On the top, we get 3x minus 9. Over here for the 6, we get plus 6x plus 30. On the bottom, we have the x plus 5, and we have the x minus 3. Well, now, let's put these together. It looks like I'm going to get a 9x plus 21 over x plus 5 and x minus 3. Okay. What we just did is we added two fractions to make up a bigger fraction. Partial fraction decomposition is taking this fraction and going backwards. So, if you have lots of room, you can use it. I always need a full piece of paper in order to do these. So I'm going to take this, and I'm going to use this and show you the technique or review it. This is, if you've already done it and you're comfortable with it, this will be a review. I'm going to take this and I'm going to break it down so that we get back to these two fractions. So, over here, this will be 7/3, page 2. So I'm going to put up here 9x plus 21 over, and I'm going to multiply out of x plus 5 and x minus 3. Sometimes you see this first as a multiplied out one, plus the 2x minus the 15. So your first job when you get that is, if it isn't already done for you, you need to take the denominator, you need to factor it. 9x plus 21 over x plus 5 and x minus 3. So you factor it like that first. Well, when you do that, we have two factors in the bottom. We're going to use those to split them up and to make two fractions. We already know, because of the way I started this, that one's a 3 and one's a 6. Okay, great. You don't know that going in though. I did that on purpose to show that we're doing the opposite. No problem. I'm not going to tell you that. You're going to have to figure it out. So right now, we're going to figure out what this one is, and we'll call it A, and this one's B. So we need to figure out what A is, and we need to figure out what B is. If we've done this right, we'll know that that's a 3 and that that's a 6. Well, let's see what we do. So, having done that, okay, what we're now going to do, we're going to take this as an equation, and we're going to multiply by the LCD. 9x plus 21, x plus 5, x minus 3 equals A, x plus 5 plus B, x minus 3. So doing this is considered the first step. That's the first thing that you would do. The second step is going to be multiplying by the LCD. So I guess for the first step, A, B, and if there's others, you do that. So when we multiply by the LCD, that's of course automatically the lowest common denominator. When we multiply on both sides, that means we've got to do it here, and we've got to do it here, and of course we do it here, but then these cancel out. So in this case, I have an x plus 5 and an x minus 3, but the x plus 5's cancel out. X plus 5 and an x minus 3, and the x minus 3's cancel out. So we have 9x plus 21 equals A, x minus 3, plus B, x plus 5. A whole lot simpler to look at this way. Okay? It'll get complicated in a moment. So, like in most of these things, if we multiply everything out, we'll probably get somewhere and be able to do something. So let's do that. B times 5 or 5b. I should have just done 5b. I'll do 5b now. It's not like mathematically wrong to do b5, but it was so unusual. It sounds like we're playing bingo as opposed to figuring out the these numbers. So now that I've gotten here, I'm going to rearrange them. And I'm going to rearrange them on purpose by putting things that are similar, in other words, things that have a common x together. These don't have anything common, so they'll be at the end. We're going to put these two together. ax plus bx minus 3a plus 5b. Okay. 9x plus 21. Oh, look, we have a common factor. Let's take that x out. Minus, or plus, negative 3a plus 5b. Notice I grouped those together. I just kept the negative with that. Makes life a lot easier. Doing this, multiplying it out, putting the x's together so we can take an x out, allows us to do the real key to this partial fraction decomposition. I want to know what a and b are. Well, this is an equal sign. What we have here is a 9x. Here we have something times x. Here we have 21, and here we have a number that doesn't have an x. These two match. A plus b is equal to 9. And negative 3a plus 5b is equal to 21. Negative 3a plus 5b is equal to 21. So, because this is in the same format, something times x plus a constant, something times x plus a constant, you can match up the similar parts of it and make them equal to each other. Same ideas with logarithms. If you had 2 to the x power equals 2 to the 4th power, x has to be 4 because the 2's are the same. Well, these x's are the same, therefore the coefficients have to be the same. And then this number equals whatever that is. So now what we have is simply a system of two equations. So let's cancel something out. It looks to me, and there, now actually let's do this. The third step is to do all of this in order to match these up. So the fourth step is to match them up, and then I guess you would solve 4b, or maybe the fifth step, is to actually solve for these. Let's find out what a and b are. And you can move the b over here as 9 minus b and plug that in for a and do substitution. I personally would prefer doing elimination. I'm going to take this one, I'm going to multiply this one by a positive 3. 3a plus 3b is equal to 27. And by multiplying that equation by 3, now these two I can add because the a's go away. 8b equals 48. Okay, looks like right. When I divide by 8, I get b is equal to 6. That looks familiar. Put the b in here. A plus 6 equals 9, so a is 3. And back up here, we put them in here, and there's the 3 and there's the 6. That means it's 3 over x plus 5 plus 6 over x minus 3. So we have just taken this one and broken it down to this, whereas before it was actually a lot easier to just put it together by using the LCD there. So those steps will work with all of these partial decomposition problems. A few of them have some tricks to them. Trick's the wrong word. A few of them are a little more complicated, but the basic idea is exactly the same. What we did here on a sort of small level, with just 2 of these, and nothing really complicating it, is the same thing we'll do with some others. So, let's do one of those complicated ones. Okay? Here's one where I'm going to throw in a little bit of a twist. X squared, okay, oops, I should do 7, 3, page 3. X squared over x minus 1 and x plus 2 squared. So that's the problem we're going to use right now. So we have a complication on the bottom. On the problem a moment ago, it had two binomials, so basically each binomial got its own fraction. Same thing's going to happen here, except we have three binomials, and one of them has a, is doubled here. It has a multiplicity of two. So what we're going to do is deal with that differently. We're going to do one fraction, and it's going to be a over the x minus 1, plus, now we use that one here, and it's b over the x plus 2. Well, you would think it would make sense that we would put c over x plus 2 also, but it doesn't. It's x plus 2 squared. In other words, this one gets used where one of it gets used here, but the whole thing gets used again. You have to do that for the third one. So if you have one that's squared, not only do you use the single factor of it once, you then use the entire squared part for another one of the fractions. Okay? And you'll see when we get done with it, it will actually work out. Part of why we have to end up with an x squared somewhere in here. So by doing this, we're going to get x squareds because we have to have an x squared to match. We have a coefficient of 1 here, and at some point, well, at the end, like we did over here, we had this is equal to that one because the x's were the same, this equal to that one. But we need something with an x squared over here to be equal to this x squared. Okay, so now we work it out. The next step is use the LCD, which is all that. So that means on this one, the x minus 1 is over there, so it'll be x plus 2 squared. The x plus 2 is there, so it's an x minus 1 and an x plus 2. And this one, that's the same as that, so we'll do the x minus 1. And by multiplying everything by it, this goes away. X squared equals a, x plus 2 squared, plus b, x minus 1, x plus 2, plus c, x minus 1. So we have to multiply it out, then we have to multiply the a's and b's into it, then we have to move them around to put them together. So let's start doing that. I'm going to do that before I put the a's with it. So it's x squared plus 4x plus 4. One of the reasons why all the stuff that you did with binomials, multiplying them out, doing squares like that, comes in very handy when you start doing problems like this.
For the a, shouldn't it be x plus 2 cubed? Since you multiply by the x plus 2 and the x plus 2 squared.
X plus 2 squared. Well, what we're doing, we're multiplying by the whole LCD, but the x minus 1s cancel out.
Okay.
So because that cancels out with that, we have only this part that we're
Okay,
multiplying by.
so it doesn't, the b and c things are kind of just to help you out and they
Yes.
aren't used for the multiplication.
Oh, they will be in a moment. I'm doing this as a step.
Yeah.
Next, I'm going to put a into each of these.
Well, I meant that the x plus 2 and the x plus 2 squared aren't used for the multiplication separately, as in to multiply the a.
Multiply the a. Wait, go ahead, please.
I thought earlier I assumed that you multiply a by what's under b and what's under c.
Oh, okay, not both. No, what you multiply by is the LCD of
Okay.
them. And because this one's already contained in it, you don't have to use it twice.
Okay.
So that's a good point. In almost all of these problems, what's under the original problem is almost automatically your LCD. And so then you cancel out one part of it, and that makes it a little easier to work with. So I'll have 4ax plus 4a. But now let's do the b's. I have to multiply this out as x squared plus 2x minus x, looks like it's plus x minus 2, plus cx minus c. Okay, let's finish these. Minus 2b plus cx minus c. So these are always worth double checking if I got first the multiplying out done right of these. X squared plus 2x minus x is plus x. So that looks right. Just making sure with these negatives I get them in the right place. A and A and A with each of these. So once you get to this point, now we put all the ones with the like terms together. Ax squared plus bx squared, and there's no cx squared. Okay. Notice I do this little technique so I don't lose one and I don't overuse one too. Next will be the ones with x's, plus 4ax, and here's an x, plus bx, plus cx. And then the ones without any x's, plus 4a, minus 2b, minus c. And then I can see that I used them all up. So this is a set, this is a set, and this is a set. By putting these together as a set, keep that x squared here, now for these, I can take the x squared out. I'm pretty proud of myself because for years, I'm so used to taking a common factor out, putting it in front. Well, that can still work, but if I catch myself and I make sure I put the a plus b in front, then that makes it easy to match this up. So if you get in that habit when you do these, it'll help you. So that means on this one, it'll be plus 4a, plus b, plus c, and the x that they all share will go on the outside of it. And this one, there's nothing to take out, so we actually just put it together. Okay. There's only an x squared. There's a reason for that. This is always ax squared plus bx plus c. If there's nothing showing, that means that these were zeros. So that's actually 1x squared plus 0x plus 0. Okay, it was a c and now it's a 0. So 1x squared plus 0, in fact, sometimes it's like nicer to write that. Put 1x squared plus 0x plus 0, because now you match that up. The x squared, the a plus b, the x squareds are the same, so the a plus b equals the coefficient. The 4a plus b plus c is the coefficient of the x, and the coefficient of the x is 0. So I have 4a plus b plus c is equal to 0. And then over here, 4a minus 2b minus c is equal to the constant, which is 0. 4a minus 2b minus c is equal to 0. So a couple of them are 0. Okay, nothing wrong with that. What we now have here is we have a system of 3 equations with 3 variables. This is nice that one of them only has 2 of the variables. That makes it a little easier. Even easier is this one has a plus and a minus c, so we can just add those two. So if we take these two and just add them, I'm going to get 8a minus b, those go away, is equal to 0. And I now have a system of 2 equations. A plus b equals 1. And 8a minus b is equal to 0. Sometimes this is even easier. I just add these two because the b's go away. 9a is equal to 1. Now that's a weird answer. A is equal to 1/9. When you get weird answers, it's worth it to go back and double check things, but I can tell you right now I know that one's right. Because I've done this one before and some of you recognize it. So now that we've got that, let's figure out what the b is, and this makes it easy. If a plus b is 1, 1/9 plus b is equal to 1, subtract 1/9. Oops, let's put this back up where you can see it. So I'm going to subtract 1/9 on this side. So 1 minus 1/9 looks like 8/9. So b is equal to 8 over 9. And then I want to do c. Well, I can use one of these. It looks like what's the easiest. I guess I might as well just use this one. Doesn't really matter. 4 times 1/9 plus that b plus 8 over 9 plus c is equal to 0. 4 over 9 plus 8 over 9 plus c is equal to 0. That looks like 8, 9, 10, 11, 12. 12 over 9? Yeah. 12 over 9 plus c is equal to 0. Now that's nice. I can do a little reducing here. 3 goes into 12 4 times, and 3 goes into 9 3 times. So I have 4 over 3. Let's subtract it. C is equal to negative 4 over 3. Those are my A, B, C. This is a good one to now look at what happens when you have fractions. Not really so hard to work with. Let's come back up and look up here. We had A over that, B over that, and C over that. Well, let's put them in those places. That's 1/9 over x minus 1 plus B is 8 over 9 over x plus 2, plus c is negative 4 over 3 over x plus 2 squared. So what I see here is this is mathematically correct, but it's not conventionally the way it should be done. We want to simplify it so we have just a number on top and a number on bottom. It can be complicated here on the bottom or on the top, but it can't be fractions like that. It shouldn't be decimals either. You should generally always keep the whole numbers on in a fraction because you're already dealing with a fraction. So what you do here is, in this case, let's multiply by 9 over 1 over 9 over 1 because I'm multiplying by 1. So I'm going to multiply by 1. Those 9's cancel out here and I get 1 over 9x minus 1. You don't actually have to multiply that out. It's okay to leave it already done and factored. I'm going to do the same thing here and multiply top and bottom by 9. So I get 8 and 9 times the x plus 2. Here, it's the 3 that I want to get rid of. And also a reminder, you don't want to keep a negative in there. If you have a negative on top or bottom, just put it in front of it, and you could move that as the negative for the whole fraction. Multiply top and bottom by 3, and I get 4, 3x plus 2 squared. Nine over 1, 9 over 1, 3 over 1, 3 over 1. Just 1 over 1 each time. That was the original fraction before we went ahead and, if this is what you had seen for a different question, which was to add and subtract these, you would now use the LCD and you multiply the tops and you put them all together and you would end up with this. That would be what you'd get if you now added and subtracted. But instead what we were doing here was to break this down to get back to the original fractions that had to be added or subtracted. Okay. Time that's left. There's a couple of different types of problems. I think there's one that I'll have you do for practice in a moment. But let me first go and show you a different type of one because notice something in common with all of these. Both of these problems had AB, ABC. It was just simply a letter on top. You've seen some of the problems in the book and some of the, what do you call them things, the solution, the examples and the problems. Some of them you ended up with a CX plus D. Let me explain why. And let's do one with that. Actually, we probably won't do the whole thing out because it takes so long to do. I'll just do the first steps on here and show you how to think about it. Okay. That was page 2. Page 3, we'll make this page 4. 4, 7, 3. So we're going to write 10x squared plus 2x over x minus 1 squared. Whoops, make that into a better way you can see it. X minus 1 squared, x squared plus 2. Okay. So, the problems that we had before, although that was an x squared, it broke down to 2 binomials. So really what happens here is that if this is a degree of 1, the thing that's up here has to be 1 degree less. So what it is just simply a number. If that's x to the 1, there's an x to the 0 up here, which is why we don't see it. Well, now we have one of them, we're going to have x squared on the bottom. The top number, or the top expression, has to have 1 degree less, which means if this is x squared, we now are going to have an x to the first power on top. That's how you know that you have to have a something times an x on top. Plus, it's a linear equation, so it's actually cx plus a number. You don't know what that number is yet, but you have to put plus d. So it's basically y equals mx plus b. So it's basically a linear equation. For all we know, it might be the other one might be a 0, but you don't know that yet, so you have to put that in. So the way you do this is we're going to treat this x minus 1 squared the same way that we did the x plus 2 squared over here. We're going to use it, and then we're going to use it again with the square. So we'll start with that and put a over x minus 1. And you now know that for the next one, we'll do the entire x minus 1 squared. So this one gets used twice, 3 times in a way. Use the whole thing here, but use only one of the factors in that one. But now for the next one, we have to put x squared plus 2, and that's your indication that because that's a square, we have to have an x up here. So we put cx, and it's always a linear equation, so we have to have plus the y-intercept that it would be, but we don't know what that is. It might end up being 0, so it might be just cx. But once we solve it and do it out, we would find out that d is either 0 or some other number. So this is what you do when you have a square. If that had been an x cubed, then you actually would have done cx squared plus dx plus e, because you have to come down 1 degree. So instead of having a cubic, you would come down to having a square, a quadratic. If you had that as x to the 4th with whatever else is after it, then you do cx cubed plus dx squared plus ex plus f. So you see how I just keep going down with the squares each time. I just have to have 1 less degree for the first one and then follow along lower. Each number one after it has a lower degree. In this case, once we get to here, that's x to the 0, so we don't have to go any further with it. Now, when you do the next part, and we'll go like 2 steps in here, and that's as far, because otherwise I worked it out before and I got down to where I'm going to go on to the second page and probably fill up that second page, so I figured let's just do the first part, because you already know how to do the rest of it. It's basically after the first step or so, the rest of it is just algebra and paying close attention, so we don't need to do all that. You're going to do enough of it with the other problems. So, when we multiply by the LCD on both sides, we're going to multiply by that on the whole thing. So that means we're going to get the 10x squared plus 2x equals a times this whole thing except for the x minus 1. 1x minus 1 gets canceled out. So we're going to have 1x minus 1 and x squared plus 2. On this one, when we multiply by that, the whole x minus 1 squared goes away, but it will be b times that, plus b times x squared plus 2. Now on the next one, we're going to have the cx plus d. The x squared plus 2 cancels out with that, but this part has to multiply to it. So it's cx plus d and x minus 2 squared. Oh, minus 1, thank you. I guess I was, yeah, okay, thank you. I wouldn't have figured that was wrong until way down at the end when I realized something's not working out at the end. So, and I'm not going to do it all the way through anyway, just because that would take us way past 305, and already I'm, I don't want to go that far. So, if we were to continue, you put all that together, and then you put a with them, and you put that with them. But think about this one, that you first are going to square that out as x squared minus 2x plus 1. Yep. And now you're going to do cx plus d times that. So if you think about it, I'm not going to do the others, but that's not so hard if you think it's cx times those. So cx times x squared would be cx cubed. Okay. So that times that plus over here, cx times the negative 2x is going to give me negative 2cx squared. And then cx times 1 is cx. Then we do it with the d, plus dx squared. D times that is negative 2dx, and d times 1 is plus d. So this one becomes all of those. When you do the other ones, you get another cube over here, so you end up with an ax cubed. In fact, show you the rest of these. So I was just working that out with all of these and running out of room in the first place, writing really small, and I'm still running out of room. But once I got where I had the a's written, multiplied out, this one, I had this one was easier. I multiplied that and then multiplied those into it. Then that cx cubed has an ax cubed to be combined with. The all the ones with squares, x squareds are here, all the ones with just x's are here, and then the ones without. So I started doing that and messed something up, and then I went down to here. Now I've got it right. Take an x cubed out of those, take an x squared out of those, take an x out of those, and the n doesn't have anything to take out of, but now this matches the x cubed, and there isn't one, so it's just a plus c equals 0. All of this matches the 10 because the x squareds match, so all of that equals 10. All of that matches the positive 2 with the x, so it equals 2. And all of that, oh, there's, when I lose myself, there isn't any constant number in this, so that means all of that equals 0. And I have a system of 4 equations, but what I did here is I took the c, subtracted the a, and if I put that in for all the c's, I now have simply a series of 3 equations, which is still a pain to do, but it's not so bad as 4. Okay? So I took advantage of there only being 2 of them here. And then I basically just said, oh, this is too much, I'm not going to do this in class, so I'm just going to show the steps up to that point. Because I was able to get that a is equal to 14 over 3, and then I decided, okay, I'm not going to go any further with it. The end result of this is that a comes to 14 over 3, and b is 4, c is negative 14 over 3, and d is 4 over 3. Put it over a over that, b over that, the c times the x plus the d. So this part, you get a c and d separately, but you still put them in the places where they were. That was the x. So that's cx plus d. The c becomes that coefficient, the d is there. And then, great that they both have a 3, because you can multiply by 3 over 3 and put the 3 on the bottom. I will not give you one quite so long on the test. You will have one, maybe 2 of these to do. What I'll probably do is give you one where you have to work it all the way out, and then a couple of them where you have to show me that you know how to take this and you know how to set it up with the cx plus d if it's necessary. Or it might not be. I won't tell you now which one I'm going to put on, but be ready for it. So that will be enough. Having to do all the rest of it, you'll prove to me one time. Otherwise, these just become too long. So I won't make it overly long. I just have to know that you can do a partial fraction decomposition. Now, what did I have? Okay. I guess I don't have enough copies here, but I do have a couple of other problems that rather than have us do here, I will put this out for you to practice on your own and see how it works. For instance, on this one, x squared over all that, there's a square and a square, you get an a, a b, a c, and a d, and I have it all worked out here. So I will show you that, or I put this up on the in the Dropbox so you'll be able to see it and try to work it out yourself and see if you can do it. I have a couple others like that too. In fact, what I'm going to say now is, let's take a moment to work this one out, okay? Write this one down, 3x squared minus 5x plus 22 over the x plus 3, x minus 1 squared. So what I'm going to say is, I don't think I'm going to need the whole class to go all the way through this, but I think it would be good to practice one because you know you're going to see one, you know you're going to have to set one up. So let's practice this one here right now, then you'll be able to go over it too. Okay? So I'm going to ask you to take the time right now, having written that down, to figure out A, B, C, Cx plus D, whatever would be appropriate, and then start using the LCD and work down the steps for it. I think we have the time to work this one in class. And then I will go through the steps behind you by a little bit so you can see if you're on the right track or not. So you can check periodically to see if you're on, you'll be a few steps ahead of me, but I'm gonna show the steps up here as I get to them, just a step or two behind you.